Hello and welcome to Section 6, Bonus Challenge and TensorFlow. Now that you feel comfortable with all that material, in this section we will propose a challenge to put all your new skills into practice. We will also talk about TensorFlow, which is a computation framework released by Google a little bit after we started designing this course. This is what we are going to talk about in this section. First, our bonus challenge, automatic image caption. In the next video, we will talk about TensorFlow, Google's alternative to Theano. Without further ado, let's start with the bonus challenge. Here it is. Can you design a deep learning model to automatically caption images? But let us set up the challenge formally. In this video, we are going to talk about the image caption problem, image captioning datasets, and finally, suggested architectures to solve the problem. For instance, how would you describe the image in this slide? Well, I would say a road in the middle of a colorful forest seen from above, or bird's eye view of a forest cut by a road. But now, let's say that we are building an image description app, or that we are adding a new feature to our social network that suggests captions to the image that we post. How do we learn the image to phrase mapping? And that is your course project, to solve the image to caption problem with deep learning. To train such a system, here are a few datasets that you might find useful. The Microsoft Cocoa dataset, Flickr 80K, and Flickr 30K datasets. Let's first check Microsoft Common Object in Context, or Cocoa dataset. Here, they provide the dataset and Python APIs to handle it. Clicking here in Cocoa Demo, we have an IPython notebook loading a few images and their description. Here's the description: a person, bicycle, car, motorcycle, and the image is this. The other two Flickr datasets are also similar. You can come to their website and download the images with their corresponding captions. Flickr 30K is slightly larger than Flickr 80K, but you should use everything that you can to train large neural networks. Next, I'll give some hints on how to solve that problem. If you don't need any hint yet, you can stop the video right now. There are different ways to approach this problem. Here's a suggestion. We could use a deep convolutional plus a recurrent neural network combo. This approach was proposed by research groups at Google and Stanford. From our input image, the convolutional neural network extracts features from the images similarly to what we did in the cat versus dogs example. But instead of training a classifier on top of these features, we train a recurrent neural network to generate text word by word. The error signal is the difference between the generated and the expected text. If you want to try to learn this full model from scratch, a Keras model to do that would look like the following. The input would be an image. The first part of the model should be a deep convolutional neural network. Here is an example of one with 4 convolutional hidden layers. After the image model, we have the text generator network, and the full image model will work as the first layer of the text generator. We could use this repeat vector layer to repeat the image model output for as long as we want our output phrases to be. On top of that, we have a 2-layer recurrent neural network with 2 LSTM layers. The final output could be 1 hot encoded words. Another suggestion here would be, instead of that image model up here, you could try to extract features using scikit-learn Theano and only train the recurrent part of the model. You could also try a different way to encode words, using word-to-vec models. I believe that training this whole system will be a massive learning experience if you try it hard enough. That being said, if you get stuck, there are a few solutions online, written in Python, Lua, and other languages that you could use as inspiration for your model. In this video, we proposed a bonus challenge that should require us to use all our new deep learning knowledge for captioning images. In the next video, we will talk about TensorFlow, Google's machine learning library.